Okay, so let's go ahead and add rational expressions with unlike denominators today. So what that means is you see these two fractions. These are called rational expressions. And we have different denominators, as you can see. They look different, right? So the first thing we have to do is find what their numerator or denominator is going to be, right? So I need scratch paper area. I'm going to use this side right here. I need to factor x squared minus 3x minus 18, right? So then we all know that we have to do the big X. So 1 times negative 18 goes on top and negative 3 goes at the bottom, right? Okay. So what times what equals negative 18 and what plus what equals negative 3? Yes, negative 6 and positive 3. Then we have to draw our fraction bar like so, and since our leading coefficient is 1, we're going to put 1 on top, and negative 6 and 3 is going to be at the bottom, right? So we put the x's on top, so we're going to have x minus 6 and x plus 3. Okay, and so that is our factor for x squared minus 3x minus 18. I mean, since I already, well, no, I shouldn't write that. So now what I'm going to do is I'm just going to go ahead and erase this. Okay, would that be okay with you now? Here. I'm going to erase it because I need to make space. So the next thing I have to do is find my LCM, right? I need to find my LCM. So I know that the factors of x squared minus 3x minus 18 is x minus 6 times x plus 3. That was too tight over there. Let me rewrite that for you. X squared minus 3x minus 18, and that would be x minus 6 and x plus 3. So then let's take a look at the next denominator. We just took care of this one. Now we're going to look at x minus 6. Okay? So what are the factors of x minus 6? Oh, we all know that it's just x minus 6, right? We cannot factor it. We cannot divide both terms by anything. And so look, we're going to use this, and we're going to use that. So our LCM is going to be x minus 6 times x plus 3. So I'm going to put that over here as our denominator. So if you think I'm going too fast, the really cool thing about this video is that you just have to pause and rewind, okay? So now let's take a look. This over here and this over here. These two fractions are the same, okay? These are like fractions. And I can see that the denominator is the same, which means all I had to do was multiply the bottom by 1 to get this one, because it's the same. So what I'm going to do is I'm going to also multiply the top by 1. That's the most important thing. You have to do the same thing. So if I multiply the top by 1, it's just going to be 3x squared minus 1. Now over here, it's a little bit different. This fraction and this fraction is supposed to look the same, or this rational expression and that rational expression. However, you can look at the denominator. This one has x minus 6. This one also has x minus 6, but in addition to that, what did we suddenly multiply? We also multiplied the x plus 3. What that means is we gotta also multiply the x plus 3 over here in the denominator. So when we multiplied that, that means we have to do the same thing to the top, right? Otherwise, all of a sudden, the value of the fraction would be different, right? So let's go ahead and do that right now. So we have x plus 2, and you got to put that in parentheses. And then you have to multiply that whole thing by x plus 3. So then now let's keep going. Since we have the same denominator now, we can combine everything into one. I'm just going to copy the front. And look over here, we're subtracting, right? So I'm going to put minus and open up a big parentheses in the back. And what I'm going to put in the back is this one right here. Okay, so let me go back to my scratch paper area because some of you know how to FOIL, but other people don't. So we have x plus 2 times x plus 3. So it's very simple. You multiply like this. It's like the distributive property, and then multiply like that. So what I do is I write the x first, and I multiply that by x plus 3, which is in the back. And then I go, I write the plus 2, and then I multiply by everything in the back again, x plus 3. This way is much easier. So x times x is x squared, and x times 3 is 3x. 2 times x is 2x, and 2 times 3 is 6, okay? So let's go ahead and combine these two because they both have x's. So it's x squared plus 5x plus 6. So we're going to put that right here. Now we have to go ahead and distribute the negative, right? So there you go. 3x squared minus 1 minus x squared minus 5x minus 6. That is all over the same denominator. We got to combine like terms again here, right? So we did this before. The 3x squared goes with the negative x squared. The negative 5x is by itself. Then we have negative 1 minus 6. Okay? So what we're going to do is I'm going to have to take you to the next page. There you go. And we'll continue on. Okay, so let's go back and see where I am. Okay, so 3x squared minus x squared is 2x squared. And then negative 5x, and then negative 1 minus 6 is negative 7. So we'll just write all of that on the next page. Okay, so there you go. 2x squared minus 5x minus 7. And our LCD was x minus 6, x plus 3. So then I'm just thinking, am I done over here? Do you remember what I said? If you can factor it, go ahead and factor it, okay? So there you go. 2x squared minus 5x minus 7. I mean, you don't know if it's going to be factored or not, so you always have to try, okay? So 2 times negative 7 is negative 14, and then the negative 5 is at the bottom, right? It looks like we can actually factor, because 7 times 2, negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. I'm going to put my fraction bar, and my leading coefficient is 2. I'm going to put the 2's on top, and my two answers, which is negative 7 and 2, goes at the bottom. This one simplifies to 1 over 1. So if I put the x on top, it's going to be 2x minus 7, and then x plus 1. You see that? 2x minus 7 and x plus 1. And this is over x minus 6, x plus 3. Can you cancel anything out? No, you can't. And so you're going to leave it like this. Okay, this is your factored simplified form, right? And then, of course, don't forget you have to put a comma. And when we started off, what did we have? Our denominator was this and that. So we got to make sure that x minus 6 is not equal to 0, and x squared minus 3x minus 18 is also not equal to 0, right? So, oops, let's go to the scratch paper area again. X minus 6 cannot equal 0. So if you add 6 to both sides, x cannot equal 6. And then x plus 3 also cannot equal 0. So subtract 3 from both sides, x cannot equal negative 3. So there you go. After the comma, you're supposed to put x cannot equal 6, x cannot equal negative 3. Okay, so we are done with this question. Now let's do our next question that we're going to see on our quiz. And that will be dividing rational expressions, right? So here's the question. X squared minus 81 over x squared minus 3x minus 10 divided by x cubed minus 9x squared over x squared minus 25. And again, we need to use our scratch paper area heavily here, right? So I like to number my equations, but before we do that, we gotta use KFC, right? So we keep this one, change this to multiplication, and then we flip the back, right? So let me go ahead and do that first. That equals x squared minus 81 over, and then I change this to times table, and then now the x squared minus 25 goes on top, right? So now I'm going to number them because I want to factor them, right? So here's 1, 2, 3, and 4. So let's do it. The first equation was x squared minus 81. We can tell that this is already the difference of two squares, right? So a squared minus b squared equals a plus b times a minus b, right? So then all we have to do is find the square root of this and that. which is x and 9, right? So then it's just x plus 9, x minus 9, okay? How easy was that? Let me just go ahead and put that here. X plus 9, x minus 9. Now let's go to our second equation over here, which is x squared minus 3x minus 10. We already know we have to do the big X. So 1 times negative 10 is negative 10. We put negative 3 at the bottom. So what times what is negative 10, and what plus what is negative 3, right? Let's see, negative 5 times 2, right? Okay. Our leading coefficient is 1, so it's going to be 1 on top of the fraction bar, and at the bottom we're going to have negative 5 and 2. We can't simplify, so just put the x on top, so it's x minus 5 and x plus 2, right? So let me write that over here, x minus 5, x plus 2. So hey, everything's going smoothly. I'm going to go ahead and erase my scratch paper area to make space for equation number 3 and 4, okay? There you go. So equation number 3 is x squared minus 25. Same thing. This is a squared minus b squared. We know this because, you know, they both have subtraction right here. That's the difference. And then they're both squares over here. And the formula is a plus b, a minus b. Again, find the square root of x squared. Find the square root of 25. Okay? So it's x and 5, right? So it's x plus 5, x minus 5. The difference of two squares is turning out to be a no-brainer, right? So everything, you know, everything has to do with practice. Now let's take a look at equation number 4, and you might feel like, oh, I don't have to factor this. But you know you're wrong, right? We have to factor by using the GCF, right? So we can divide both by what? We can divide both by x squared. So what we're going to do is we're going to pull out the x squared and actually divide it. So if you divide, I have 1x left. If you divide over here, the x squared cancels out, so I got minus 9. And we know that we cannot factor this one anymore. We're done, right? So we're just going to write that. I thought the x minus 9 here for a second was the difference of two squares, but it's not. From here, we just have to cancel stuff out, and it has to look exactly the same, and you can cancel one from the top and one from the bottom. So we have x minus 9, top, bottom, x minus 5, top, bottom, okay? So now what do we have left? We have x plus 9 times x plus 5 on top left. The bottom we have x squared and x plus 2 left. And of course, we're not done. Remember what I said? Look at the original question. The denominator is these two, right? So we got to make sure that those are not equal to 0, right? So the factor form for this was down here. So x minus 5 cannot equal 0. Let me write that again. X minus 5 cannot equal 0. And then x plus 2 cannot equal 0. And then what's the denominator here? Oh, it went up over here. So x plus 5 cannot equal 0. And then x minus 5 cannot equal 0, but it's already here. So basically that would be 5, that would be negative 2, and that would be negative 5. So here's your answer. X cannot equal 5, x cannot equal negative 2, x cannot equal negative 5. So this whole thing is your answer, okay? So I hope you do a great job tomorrow, all right? Happy learning.